Okay, so welcome everybody. My name is Sid Sipes. By way of quick introduction and background, I work at SAP. I am in the what we call the go-to-market group. I'm the guy responsible for taking a product that engineering or our partners have developed and then bringing it to market, training our field on how to sell it, working with customers and so forth. We're going to talk about what we've been doing around IoT lately, kind of look at an overview of IoT from an SAP perspective, why it's so important to us, besides money-wise, but why it's become so important to SAP to recognize IoT and to handle it. We're going to look at a little bit of level set on what we think IoT is and what the edge actually is, just so we're all talking the same terminology. Then we're going to look at how we're handling it, our strategy, and what we're doing with partners like Red Hat. I'm going to describe a prototype we built to handle edge compute with Red Hat, but I'm not going to show the demo. We actually have, to see the demo, I invite you to come down to either the SAP booth or the Red Hat booth, where we can show you live the processing capability we've built. Finally, I'll just quickly summarize with some use cases. So let's go ahead and start. So why is this so important to SAP? Well, besides money-wise, and I'll speak to that in a second, it's become really important because our customers are starting to ask us. You guys know SAP as the company that runs businesses. Companies run our ERP software, our CRM software, so we're known as, the business company or the application company. Well, most of our customers now are asking us, hey, we're getting all this data from all these devices and sensors out here. We really need to be able to combine it with your business data and make use of it. And not only combine it, but do it in real time. So the requests from our customers are getting really serious. And on top of that, when we started looking at the market potential, the light bulb went off. We have to satisfy our customers, and there's a huge revenue potential there. So speaking of that, if you look at what IDC says, and if you've been to any other presentations, you've probably seen similar numbers. IDC says that the IoT market's going to be about $2 trillion in a few years. Now, of that $2 trillion, they're saying 32% or so is strictly at the edge for the devices and sensors. So there's a huge opportunity. 32%, what is that, 800 million? Just for the edge computing and devices. That's a huge revenue opportunity for anybody. And in addition to our customers asking for it, that's another reason we've jumped on it. Now, of that, what they're saying, what is going to happen in the IoT market, I mentioned that we have all these devices out there producing data. They're producing a lot of data. It's causing a lot of issues, and I'll go into details on the issues in a few minutes. Because of the issues, we're starting to see the case to actually handle the data at the edge, process the data, store the data, handle it closer to where it's produced, rather than the typical model of send the data to the corporate center, do something with it, and send it back. So again, another IDC estimate is in the next couple of years, the model's going to be changing from processing at corporate to 40% of the data will be processed at the edge, closer to where it's produced. So that's even more reason for us to handle this request. So I'm going to show you our strategy. I'm going to show you what we're doing. I'm going to show you what we built with Red Hat. But first, I kind of want to back up and just level set with some terminology. So IoT is a really big buzzword now. Everybody's talking about it. Everybody's saying they're doing things with it. So what I want to do is show you, from my perspective, what the terminology is. So when I talk about the edge, I'm talking about those things out there that produce data. It could be anything from, an iPhone, a mobile phone, an iPad, things we carry around, to sensors in an airplane, sensors in a car, sensors on a factory floor. There's a lot of stuff producing data, and every day there's more and more stuff producing data. If we look at just the handheld devices, the mobile phones and so forth, right now I think there's approximately 20 billion devices out in the world producing data. That's 3 times more handheld mobile devices than there are people on the planet. So if you combine that with all the sensors out there, think about sensors in airplanes. Think about the sensors in a factory, on an oil rig, in a car. Now you get into the billions and billions of devices producing data. All of those devices have to transmit the data. And as I'll show you in a few minutes, this is where a lot of the problem starts coming in. How do I get that data from where it's produced to where I need it corporate? How do I get it effectively, reliably, and quickly? Internet, sometimes it works, sometimes it doesn't. Some of the devices are talking over radio, some of the devices are talking over satellite. So there's a lot of different transport mediums out there. And They have different bandwidth requirements, different bandwidth limitations. So you have these tens of millions or billions of devices producing data, trying to talk over limited bandwidth. And then, of course, the core. This is where the data is used. This is where the data is processed. So just to level set, when I talk about edge or core, the edge I'm talking about where the data is produced, and the core is the typical business data center. If we look at the different pieces SAP has, and I'm not going to really go into this, we basically have at the core, we have a system called SAP HANA. And HANA is SAP's flagship product. It's the in-memory database. It's what all of our applications run on. It's the next generation database platform. Not really here to talk about that, but you'll see, I wanted to put it in context here because you'll see it in some of my architecture slides. But as we talk about this, keep in mind that I'm SAP-centric. But when I talk about edge processing to corporate processing, when I'm wearing my SAP hat, it's going to be HANA. But in reality, we can talk to anything. We can talk to anybody's data center. So I mentioned a little bit about the data that's out there, where it's coming from. We have different kinds of data. We've got the data coming off the mobile devices. We've got social media data. We have a lot of retail applications. Our customers are saying, you know, people out there talking about me right now. I want to know what they're saying. I just released a product. I need to know how it's being received in the market. So I want to know it, and I want to know it now, and I want to be able to react to it now. So we're getting social media data. By the way, it's not only what the users of the mobile devices are saying, it's the fact that they have a device and it's transmitting data. So just the fact that there's data from a location is becoming important. So we've got social media data, we've got mobile data, we've got data coming off sensors, we've got data coming from other devices. We have a huge amount of data, all being required, all being necessary. Let me go ahead and click through this. So what we end up with, and I know you've seen this in everybody else's presentation, we end up with what's becoming the convergence of IT and OT. IT is the typical data that we run our business on. OT is the operational data or the outside data. So all of our customers are now saying, hey, I need to combine that OT data. I need to take that data from people's social media. I need to take that data from that airplane. I need to combine that in real time with my business data and make decisions on it. I kind of threw this slide in there. It's a little whimsical and funny, but there's all that data being produced out there. Everybody's talking about ways of collecting it. Everybody's talking about ways of storing it. But in reality, having that data isn't really valuable. It's making use of it. And the real value comes in making use of it in real time. And that's what we're going to talk about now, is what's producing the data, some of the problems with collecting the data, transmitting the data, and then how we can make use of it, which leads us into our compute strategy. If we look at a really simple diagram, we have all of these things out there in the world, connecting via the internet, talking directly to our corporate business centers. We could have people, we could have phones, we could have sensors, we could have cars. By the way, last year, the FCC approved the connected car. That means that every car can now transmit data on the fly. And I bet you didn't know, but a lot of them do. They're collecting data as you drive, and they're transmitting it to somebody. The average General Motors car produces about 3 gig of data per hour. It's being used, collected, and sometimes transmitted. My wife bought a new car last year, and about 6 months in, we started getting emails from BMW saying, hey, your car's telling us you have a problem. Your car's telling us this, please bring it in. We didn't even know it was transmitting data. But in addition to using the data for problems, we have other customers who are saying, you know, if I just know where people are driving and driving patterns, I don't even need to know who they are. I can use that data to maybe provide better traffic information. I can use that data to provide better information on what kind of tires I might want to sell them. So even just the fact that there's data at a location is becoming useful. If we break it down further and look at the architecture, we have all of these devices out there talking over the internet, talking directly into our data center. Data comes in via either directly in or into one of our streaming systems, goes into HANA. HANA starts making decisions. If any decision is critical, then that gets relayed back to where it's produced immediately. This has worked pretty effectively for a long time. The problem is, again, I mentioned earlier, the number of devices transmitting is growing exponentially. Recently, in order to handle the huge amount of data, we looked at it from one side of it, which is, okay, I'm getting these terabytes and petabytes of data. What do I do with it? Well, I mean, the obvious answer is we need somewhere to store it efficiently. So we've added on a Hadoop capability to our system. So now we can accept the huge amounts of data. Now we can process it as it comes in. And now we have a way to store it and retrieve it efficiently. So this is a pretty good architecture. This works pretty good until we start running into some of the problems that I'm going to show you in just a minute, which are the tremendous amount of data. There's only a limited amount of bandwidth in the world. Everybody is saying, with the recent airplane crashes, everybody's been saying, why don't airplanes transmit all of their cockpit data and their FDR data in real time? Well, there's a bandwidth problem. Everybody's using bandwidth. TV stations using bandwidth, radio stations, personal radios, people on the internet are using bandwidth. There's a limited amount of bandwidth out there, and there's far more devices producing and consuming data than there is bandwidth. There's also areas of the world where there is no bandwidth. I mean, you're out in the mountains or you're out in the middle of the ocean, you may not have any connectivity, so we have to be able to handle that. And then perhaps more importantly lately is, in addition to connectivity or bandwidth, is I need to respond immediately to something that's happening. I can't wait for the data to come in, go over the internet, go into my system, be processed at corporate, a response figured out, and then transmitted back. I can't wait that minute or 2 minutes or 3 minutes, hours maybe. I need to make a decision right away. Think, for example, if we're monitoring an oil pipeline or gas, oil and gas rig. We're watching pipeline pressures. We can't wait for that pipeline pressure to be transmitted back to corporate and then a warning come back that the pipeline pressure is rising. It's much more effective if we had a device closer to those sensors that could be running a rule set, looking at the data, running some rules, and then determining there's a problem and responding to it right away. So responsiveness is becoming one of the key issues we have. Also, corporate priorities may be different than what's out at the edge. Yeah, these pipeline pressures are coming in, but it's the end of quarter and I've got to run reports. That's taking my processing capability. We also have connectivity issues. What if the connectivity goes down as that pipeline pressure is spiking? So you kind of put all these things together, and you can see how we're starting to hit some bottlenecks. We're starting to see some real problems with the data that's being produced at the edge. Okay, to complicate matters, there is no standard at the edge. We've got all kinds of devices. We have high-powered devices. We have low-powered devices. We've got a lot of computing power in some places. In some places, we have the equivalent of, a single board, 16-bit computer producing data. We've got different capacities. Some devices are producing a high amount of data. Some devices are producing a low amount of data. Bandwidth is different. Sometimes we have high bandwidth. Sometimes we have low bandwidth. Sometimes connectivity is there. Sometimes it isn't. Sometimes we have to respond in real time. Sometimes we don't. So the fact that there is no standard for the edge and what we have to do really complicates matters on how we handle data at the edge. SAP and Red Hat, about a year ago, sat down and said, okay, we need to handle this. What do we need to do? What are some of the major requirements that have to be handled? And we came up with these. Now, this is not all-inclusive, but this is what we saw as the most important. So first of all, because of the bandwidth issue, we need a way to reduce the amount of data coming from the edge. Maybe we could aggregate it. Maybe we could filter it. A lot of devices sometimes just produce a ping or a handshake every second, and it's not necessary to transmit or capture all that data. You can handle it closer to the edge. We need to be able to handle offline operation. For example, the oil rig. When we don't want the oil rig to shut down, we don't want its processing to shut down just because the internet went down. We need to be able to store data, local persistence out there. When the connectivity goes down, we don't want to lose data. We just don't want the devices out there blindly throwing data into the bit bucket. So we need to be able to persist it. I mentioned immediate response is one of the key features. We need to be able to respond quicker. If that pipeline pressure is spiking, or if we take from the recent headlines, if something's happening on an airplane, we need to be able to react much quicker than we do right now. And then this local applications, this is becoming more interesting and actually more important. We're starting to see some requests to actually run analytics and applications at the edge. So for example, think of a factory floor. Right now, we can collect data, we can transmit it to corporate, and they can store it and run the reports on it. But what about the factory floor manager? He may want to see what his machines are doing. He may want to see immediate alerts. He may want to run his own analytics. He may want to run his own applications. So in addition to collecting and processing and storing data at the edge, we're starting to see requests to do analytics or applications out there at the edge. So this are really the main categories we decided that we needed to solve. So what did we do? We came up with, the answer was really pretty apparent. We needed to move processing power from corporate to the edge. We needed to be able to take a lot of what was happening in that corporate data center, the HANA system for the SAP-centric one, and move it out either to the gateway or maybe even onboard the device itself. We actually had all of the components sitting around in place that we could put together and solve this problem. And I'm going to describe that architecture here in just a second. From the SAP side, we have a system called SQL Anywhere. This is actually something we inherited from Sybase. SQL Anywhere, I'm going to give you a better description in a minute, but SQL Anywhere is a database and data processing system that was designed in the 90s to be an embedded database engine. It was designed to go on very small devices. It's a full enterprise-scale database, but it's designed to be put out in remote locations where there's no DBAs. It can run in as little as, this is an interesting number, 5K of memory. Not 5 meg, but 5K. So it needs very small resources. So we can take that and we can put it on the gateway. We can put it on a single board computer. And I'll show you its capabilities in just a second. So if we look at the picture we had earlier of the architecture, instead of streaming all that data directly into the corporate data center, now we can stream them into a gateway with SQL Anywhere running. This gateway could be an off-the-shelf internet router, internet gateway. Everybody sells them, Intel, Dell, Cisco. Everybody sells these gateways and routers. We now can put our software directly on these off-the-shelf devices and start processing that data closer to where it's being produced. We can capture it, we can store it, and then with the synchronization capabilities we have, we can immediately synchronize back with corporate. If connectivity goes down, SQL Anywhere will store the data. It'll know when connectivity broke. When it comes back up, it restores the data flow, and it restores anything that was missed from either side. So now we've solved a couple of the abilities I talked about. The ability to reduce the bandwidth, the data, the ability to store data, and the ability to operate offline. So what about responding, responsiveness? Well, we can add other processes to it, and this is where Red Hat came in. Red Hat had some JBoss middleware software that we added to SQL Anywhere that enabled us to put a rules engine on the gateway. So now data can come in, it can be stored and processed, but we can also start running it through a calculation or a CEP or a rules processing engine immediately. So now if that oil pipeline pressure is spiking or something's happening, we can handle it right there. Even if we're not connected to corporate, we can handle it locally. And the architecture that I'm going to show you and the demo that you can see if you come down and visit us will show you this architecture. So I mentioned that the key component from the SAP side is SQL Anywhere. This is something that's been around since the early 90s. It was initially designed not to be a database, but to be an embedded data processing engine. It was designed from the scratch to go where DBAs aren't. It was designed to be self-starting, self-healing, self-tuning, everything that needs to be done without a human being present. We've been doing it for a long time. We've got about 13 million seats of this out there, so this is not something new. We've been doing it forever. It works really well for what it does. It's in a lot of critical applications, and we chose that for this new application because it's seemingly designed for it perfectly. Now, if we back up and think about it for a minute, it was designed to be an embedded system. Well, that's exactly what we're building here, an IoT gateway. We're using new terminology and fancy buzzwords, IoT gateway, IoT client. But what we're really talking about is embedding software in a small device to handle data and processing in a remote location. And that's something we've been doing forever. Now, the marketing people asked me to put this in. If anybody's interested in building IoT system, if anybody's interested in duplicating the system we built with Red Hat, we're offering a special right now. By the way, this is a very inexpensive product anyway, and we're offering a 15% discount for the next month or so for the show. If anybody needs any more information on SQL Anywhere, come down to the booth, and I'll be happy to spend hours talking you through its capabilities and what it can do. So now, Okay, I've shown you SQL Anywhere, I've shown you some of the things we can do. Now I'm going to put it together in a big picture of what we've built at SAP and what we built with Red Hat. We've always had the core processing. This is the corporate data center. This is where SAP has been forever. This is where we've excelled. The corporate applications, the business process, the business programs. We've added a lot of features to handle big data. We've added a lot of features to handle IoT data. So we've always excelled there. And now with Red Hat and other partners like hardware partners like Dell and so forth, we now have a capability to extend some of what we've done in that corporate data center to the edge. So now we can handle those issues of being occasionally connected. Now we can handle the responsiveness or latency issues. Now we can handle issues where the network traffic might be bad or signals may be interfering and so forth. Let me just go ahead and click through this. Now we have a complete end-to-end system. We can collect data at the edge. We can process it at the edge, transmit it over many different types of protocols, and then process the data at the core. So for the first time, we can go end to end, all the way from the device that's producing data, all the way into the core, and as I showed you earlier, all the way into a Hadoop type system for storage and analytics. If I break it down, the architecture a little further, I figured this was a developer conference, so I should show some developer type slides. If we break it down a little further, what we end up with is HANA and all the corporate processes and applications surrounding it on one side. Now being able to connect and use data from the edge and all the processes that we have available between SAP, Red Hat, and other partners available on the edge. Put it all together with partner ecosystem, and we have a full-blown end-to-end system. Remember that picture I showed you of all the data streaming from the devices directly into our corporate data center? Well, now what the picture looks like is we have devices streaming into local nodes. Again, it could be a gateway or an internet router, being processed there, and then the resultant data, much reduced, flowing into the corporate data center. And those edge nodes, we could have a hierarchy of these. We could have one edge node talking to 3 out in the field, which are talking to 6 more. So basically, we can scale out almost infinitely and handle almost any amount of data that's being produced out there. It's not just SAP. I kind of want to emphasize this. I keep showing you in there the purple parts that come up talking about partners, but I want to emphasize this is not an SAP-only system. We're heavily dependent on our partners to produce that end-to-end system. The hardware, the operating system, the rules engine, and so forth. So with partners like Red Hat, we can take the best of all breeds and assemble and put together a complete system, which is what we've done. So we've built this gateway. Actually, let me show you the architecture. We built this gateway. It's up and running. It's down in the booth, where in the demo we're feeding it simulated data, but the prototype is real. So we built this prototype that's taking the simulated retail data, people walking around a store, people shopping for stuff. Some of them may have the store's application, some don't. But watching what's going on, being able to pull up shopper's history, being able to recognize when a shopper may or may not take a purchase, and then react immediately, all sitting on a router in the middle of the store rather than some corporate data center in Chicago. So I urge you to come by the SAP booth, and we'll give you a much more detailed look into this demo or prototype, and we'll actually show you it running. I also want to mention that this isn't something new we've been doing with Red Hat. SAP and Red Hat have been working together since the 90s. Red Hat was the first Linux system that our applications came out on back in '99. So this continues a history of innovation. This prototype continues a long history of innovation we've had with Red Hat. So we're getting near the end. I kind of want to wrap it up by showing you just some of the use cases that we've seen out in the field. I've kind of talked around them a little bit, but I thought I'd go ahead and show you the use cases and then summarize it with how we met some of those requirements. So the first use case, and these are actually based on systems that we've already built out there. First use case is basically we have customers that want to collect data and store it at the edge. They want to make sure that they don't lose any data. So the first use case is just basically ensuring that the data gets collected and nothing gets lost. Data comes into the gateway. Do you guys like my fancy graphics? Again, developer conference, I thought maybe it'd be better to, rather than have some slick corporate marketing person do the graphics, I just drew it myself. Another use case, and this one is actually the one that's rising to the top rapidly, being able to run applications or analytics at the edge. You know, that factory floor guy may want to run analytics on what's going on in his factory. He may want to run some predictive maintenance algorithms. He may want to know when a machine needs to go down for maintenance and so forth, without having to call corporate up and say, I need to run this, and then being told, no, we're running the end of the day reports. You can't do it now. You have to do it at 2 a.m. So we're seeing more and more requests to run analytics at the edge or local applications out there at the edge. And then finally, we're starting to see some requests for even bigger applications at the edge. So a good example would be running a system on an oil rig. So you guys know SAP has systems that you run your business on. Some of those are things like staffing and scheduling and so forth. Well, a lot of our customers are oil companies that have these rigs out in the Gulf. And what they found is that on the rig, a lot of the, say, the HR applications, the scheduling and staffing applications worked great until connectivity went down. Then nobody knew what to do. So what we ended up doing was taking a version of those large applications, putting them on a gateway with that SQL Anywhere process, so if connectivity goes down, they still are able to do their work. They're still able to get their staffing and scheduling done. So in addition to the small analytics and applications, now we're starting to see requirements for some big ERP type stuff out on the edge. So those are just some of the use cases. And kind of to wrap it up, the architecture I've shown you, I think we've handled all of those requirements that Red Hat and SAP sat down with and talked about a year ago. The ability to reduce data. We can collect it, we can store it, we can aggregate it, we can only send to corporate what's needed. We can filter out the pings and the handshakes and make sure that we're taking good advantage of what limited bandwidth we have. We can have the ability to run offline. Connectivity goes down, the oil rig continues running. We can store data out at the edge. So again, that's a connectivity issue. If connectivity goes down, we make sure that no data gets lost from either direction. When connectivity comes back up, we fully synchronize the data both ways. We can provide immediate response. When that oil pipeline pressure is spiking, there's a gateway or a device sitting right there near the pipeline that can run the rules and respond, either send an alert or maybe take some action like reducing the pipeline flow immediately. And finally, we're starting to see again the requirements for those applications. I want my oil rig to run completely. I want my big applications to run when connectivity goes down. So we think with this gateway, this prototype that we built, we've successfully handled all these applications. And in reality, it's not just we think, we know we've handled this because we fielded it several times already. So we have, with oil rig is an actual customer I told you about. The comment I made about the tire store wanting to collect tire data from people driving, that's a real instance and so on. So we've fielded this thing, we've had great success with it, and we think it's the best method of handling those problems caused by the mass amounts of devices out there. So at this point, that's basically it. I know we did this pretty quick, but I promised you about a 30-minute session. So if you guys have any questions, I'd be happy to take those questions now. Yes, so I'm supposed to repeat the question. So she asked if the demo is downstairs. Right, we're running the demo of the IoT Gateway in the SAP booth and also in the Red Hat booth. So both locations. Any other questions? Well, you have a question? Oh, okay. Well, I appreciate it. Thank you all for attending. If you have any questions, please come down to the SAP booth. This is my favorite topic. I'd love to talk to you more extensively about this. So thank you very much.